And here we are with part 2 of defining and measuring variables. If you look at your syllabus, you can see that this corresponds with the second half of chapter 3. And there is also an associated lecture listening check as a participation assignment for this lecture. We're going to cram a lot in today, so I hope you're ready for this. Because measurement is sometimes the topic of an entire semester. You can take a course on tests and measurements. I think we even offer one at MCC. Derek Borman teaches it. I don't know if it's on the schedule every semester, but it's a very large, broad topic, and we're going to try to boil it all down for you and hopefully fit the second half of this into just 1 hour. So let's get going. I left you off last time with part 1, where we were discussing limitations of operational definitions. And I don't know if you watched that little video on operationally defining the meaning of life, but the psychologist there is making the argument that we can pretty much measure everything. And I think I talked to you a little bit about the controversial nature of that claim, how I'm not sure I'm totally in agreement with that. Because operationally defining these constructs does require veering away from empiricism to some extent and requires more inferences. So that's why methodology sections of manuscripts are important, so that you can read to see if you agree with how the authors have operationally defined their variables, if in fact they are these hypothetical constructs. So there was a little concluding statement on that. Moving on, you should be aware that there are various ways of gathering these numerical data points. An operational definition yields numerical values because, as I said, this is quantitative research methods. So what methods or modalities do we use to go about acquiring those numerical values? Well, there are 3 basic ways of doing that: self-report, behavioral observations, and physiological measures. That's just how they're categorized. So with self-report measures, you are asking participants to subjectively report about their own experiences. So you're asking them. And that's what I mean by subjective. It's not objective. It's not observed by a third party. It is reported by the participant themselves, hence the word self-report. And this would include things like questionnaires, surveys, even interviews. So it could be paper and pencil. It could also be verbal, as through an interview. But you are asking people to quantify their own experience. So like on a scale of 1 to 10, how good do you feel your self-esteem is? Oh, I think my self-esteem is a 10. I don't know. Okay, so I'm attaching that numerical value to it. So you could use interviews, but you could also use self-report. And that, paper and pencil measures, which is actually the most common type of self-report. But either way, interview, paper and pencil, there are various ways that you can design these questionnaires to ask participants about their experiences. And what you see here are some examples of that. You can ask participants a question in an open-ended way. So if I was doing a study, let's say, on common living arrangements in college students, if I ask them in an open-ended manner, it would be like an essay question. I might say, please describe your living situation. And that could be, again, through interview or a paper and pencil measure, but it's like an essay. The beauty of that is you will capture all possible living arrangements. So if they're unique or unusual, or something that you hadn't thought of before, you didn't have to offer that to the participant as a choice. They could come up with that spontaneously. So they might say something like, you know, I live with my adopted mother and her sister, okay, which is probably not a frequently occurring living situation among college students, but you've been able to capture that by using an open-ended item. Another option is called a restricted item, and that is where you offer participants limited options. So you give them a list. Choose the item that best reflects your living situation. So you might offer common living situations in college students. I live with a roommate. I live with my parents. I live with a sibling. I live alone. So giving them choices and they select one. Now, the advantage of that over the open-ended item is that because we are numerically coding these responses, remember you have to have a number attached to the response, the advantage is that you don't have to come up with a unique code for all these different unique situations. You're just giving them a limited number. I think I listed 4. So they get a 1 if they say they live with a roommate. They get a 2 if they say they live with their parents, etc. So that's an advantage of restricted items, which is, of course, a disadvantage of an open-ended item. If you have got essay question responses coming in from 100 participants, you're going to have to figure out how to code and numerically attach a numerical value to all of those different potential responses. So advantages of open-ended are that you capture all responses. Advantages of restricted items, you don't capture all responses, but they are easily numerically coded. If you want kind of a happy medium, you could choose partially restricted items. So, for example, you could say, choose the item that best reflects your living situation, and then leave a space for them to respond if they have a situation that is not offered to them in those restricted items. That's sort of trying to capture the best of both worlds. You're going to have a little trouble coding all of the different potential responses to that other item, air quotes, other. But most people will probably choose those numerical items, and you don't have to read through all of them and interpret them the way you would if they were all open-ended. Another way of delivering items is rating scales, and that is using items that have numerical values attached, and those numerical values are labeled. I'll show you an example of this in a couple of slides, but so for rating scale items, you can use, say, a scale of 1 to 7. How good is your self-esteem? Where 1 is very poor and 7 is very high, and there's a neutral point of 4 kind of in the middle where it's neither high nor low. When you use a 7-point scale like that, it's called a Likert scale. Now, a Likert scale is the most commonly used scale in psychology, and I'm not really sure why that is. Other than 7 points on the scale represents a number of points that gives you enough variability in scores to do a correlation, and it's an odd number, so it gives you that neutral middle point, which is 4. You can label those numbers in terms of frequency, like how often does something happen, agreement, how strongly do you agree or disagree, how important is something to you, what is the likelihood or probability of something happening, or the quality of something. So rating scales are actually really pretty flexible and probably the most common way that paper and pencil self-report measures are constructed. Now you'll have to decide if you want to label every single point, or if you want to say, for example, only anchor the ends. The difference being, if you anchor only the ends, you're allowing the interpretation to fall to the person. Okay, so if I only know that 1 is not at all and 10 is very often, then, or 7 is very often, then 2, 3, 4, and 5 are kind of left up to my own interpretation. If you want to more rigidly control how participants interpret each of those numbers, then you can label every point. The second modality or way of gathering those numerical values is behavioral observations. And this is more of an objective report. Okay, so whereas self-report is subjective, it's coming from the person themselves, behavioral observations are coming from another person. So I am the researcher and I am making observations of participants and I am recording their behavior. Now, obviously, one of the advantages of this is that it's a little more objective. It's not subjected to the person's own filters. But that's also a disadvantage. It's then being interpreted through my filter. There are also various ways that you can attach those values to behavioral observations, and they are frequency, the frequency method, duration method, and interval method. I'm going to use a little example to explain to you the differences between these three methods of making behavioral observations. And it goes like this. Okay, so when I was in the master's program, we had to go collect data at this day program for kids who, at the time it was called just autism, but now it's called autistic spectrum disorder, but they were kids who had autism at the time, and it was called Institute of Logopedics. This was in Wichita, Kansas. And one of my mentors was collecting data and doing a research project there, consulting with them. And so he asked us to go in and collect some data. Well, we had some decisions to make about how to collect data and make observations on some problematic behaviors that the staff were seeing from the kids who had autism. And there were 3 behaviors in particular that were causing trouble, and they wanted to get some data on these behaviors so that they could tailor some intervention to these behaviors. One of these behaviors was called elopement. And elopement, I don't know why they called it. It's like people eloping to get married. But what would happen is the kids would be sitting in their seats working on something, and then all of a sudden, some kid would get an idea in his mind that he didn't want to do this anymore, so he's going to make a break for the door and try to run away. That was elopement. So they were concerned about that. The second behavior that they were concerned about was self-injurious behavior. And so commonly, especially among the more poorly functioning kids with autistic spectrum disorder, they will engage in behaviors like biting themselves, head banging. Some kids will repeatedly punch themselves over and over and over again. So self-injurious behavior was a worry for the staff. And then the third behavior, which wasn't dangerous or anything, but was still interfered with the learning process, was called stereotyped behavior. And that is repetitive self-stimulatory behavior, like hand flapping, this kind of thing, to provide themselves with visual stimulus, or rocking back and forth. So self-stimulatory stereotyped behavior was a distraction in the learning environment. So they wanted us to collect data on those various things. Well, each of these behaviors calls for different types of methods to gather data about their occurrence. So, for example, on the issue of elopement. Elopement is a very discrete behavior. It's sort of a thing where you know it when it is happening because you see the child get up from their seat and then run for the door. So in that instance, we decided to use the frequency method. The frequency method is used by isolating a target participant for a specific or specified period of time. So for this 5 minutes, I'm watching target child number 3. And I am counting the number of times that behavior occurs within that 5-minute period. So that's a frequency method. How many times does this child get up from the seat and make a break for the door within this 5-minute period of time? And it doesn't have to be 5 minutes. It could be 10 minutes. It could be 30 minutes. That's up to the principal investigator. So that's the frequency method. The second method is called the duration method, and we decided to observe the stereotyped behavior using the duration method. And again, you have a specified time frame during which you're observing the target child, but instead of counting the number of times something occurs, you track how long the behavior occurs within that time interval. So if a child is visually self-stimulating by a behavior like this, that's hard to track using the frequency method. So is every time they do this 1? It's not a discrete behavior with a clear-cut beginning and end, and it occurs at very high rates. So we use a duration method. During this 5-minute interval, I started the stopwatch every time this behavior began, stopped it when they quit. If it began again during that same time frame, start the stopwatch again, stop it when they quit. So that's just how long during that time frame the behavior occurred. And then interval is used with similar behaviors to stereotype behaviors that don't have a clear-cut beginning and end or occur at very high rates. But with the interval method, you're really only interested in whether the behavior occurred or didn't occur, and that's the easiest one to use. So with self-injurious behavior, it wasn't as relevant for us to know how many times the child bit themselves or banged their head on the wall, because we didn't want any injurious behavior occurring at all. So in that case, you only record, did the behavior occur during this time frame or didn't it? So again, in each of these, you have a segmented, identified, specified time frame. With interval, I'm watching this child, participant number 3, for 5 minutes. And if the child even bangs their head 1 time, that is a yes. If the child bangs their head 20 times, that's a yes. If none of the behavior occurs, that's a no. So that is the interval method. And those are the 3 methods of implementing the behavioral observations modality. Physiological measures are pretty straightforward. This requires the use of equipment. What's nice about these is they're not very dependent on interpretation because you're getting some objective numerical measure just by using the equipment. So an example might be something like blood pressure or heart rate, palmar sweat, measuring palm sweat for anxiety. The problem is that it does require the use of equipment, and sometimes that's expensive, especially if you're, trying to collect data about something that's not very common or accessible to students, like blood sugar levels or something to do with blood serum. So physiological measures measure physiological changes. They do tend to be more objective. So here is an example of a rating scale, like what I was telling you about before. So this is not a true Likert scale. This is a 5-point rating scale, but it does have a neutral middle point, which is a 3, undecided. And this is just an example of rating your attitudes about mathematics. And see how they've just provided one standard line up at the top to make the comparison to answer each of the different 5 questions, okay? So a 5-point scale isn't a Likert scale, but that would be acceptable. But as you can see, it doesn't have as much variability as a 7-point scale. It has more variability than a 3-point scale. So I think just for whatever reason, 7 has been commonly agreed upon as a suitable amount of variability with a neutral point. Now, you could use an even number of items if you did not want participants to have a neutral point. So let's say you wanted to force participants to either agree or disagree with a statement, then you could do an even numbered scale, and 1 and 2 would be disagree, 3 and 4 would be agree, and then they would be prevented from endorsing a neutral or not taking a position on something. So it really all kind of depends on the goal of your research. All right, so now we need to talk a little bit about psychometric properties. We've talked about operationalizing variables, how you define them. We've talked about how you gather that data. Well, how do you know that these measures are adequate? How do you know that these are good and acceptable measures of the variable that you are attempting to measure? Well, you need to consider reliability and validity of those measures. Here we have a lady getting on and off the scale. I actually got that off an eating disorder website. And her getting on and off the scale is illustrating for you the concept of reliability. What is reliability? Well, a reliable scale is one that consistently produces the same results. If this gal gets on the scale and gets 1 reading and then gets off and gets back on the scale and gets a 2nd reading, that's not a reliable scale because nothing has changed in the interim. She hasn't gone and eaten a heavy meal. She hasn't exercised and lost weight. She hasn't put on heavy clothes. And so you would expect that consistency, right, in the readings over time and other factors. If nothing else changes in the interim, that scale should yield the same measure. So a reliable instrument will produce similar results when the measure is repeated. Why is that? Well, if you've ever gotten on and off a scale, you probably know that sometimes when you get on it, it'll give you one measure and then you get off. Nothing has changed. You haven't moved the scale. You haven't eaten anything. You haven't changed clothes, nothing. You get back on and there is a little bit different reading there. Well, that is because for every score consists of a true score plus error. So what does that mean? Well, this lady has a weight. She obviously has an accurate weight. There is a weight that exists for her in reality that is her true weight, and that is the true score. However, there are contributions to the measured weight that don't reflect her actual weight, and those are error. For example, if she changed clothes or if she moved the scale from a hard surface to a rug, those kinds of things are, or if the scale needs calibrating, that's another possibility. All of those things contribute to error, which cause or result in fluctuations in the measured score. If you want to minimize the amount of error in your score, if you do minimize that amount of error, that will result in better reliability. So measuring yourself, weighing yourself the same time of day, wearing the same amount of clothing on the same surface, all of those kinds of things will result in better reliability. All of those measures that you take that I just described are called standardization. So measuring the construct under the same conditions every time is standardization, and that will result in better reliability. Over several measurements, error will average 0. So as this lady gets on and off the scale, she might sometimes weigh a little more, she might sometimes appear to weigh a little bit less, but over several measurements, that error minimizes and approaches 0, the more times you measure, of course. So multiple measurements are a strategy that are also sometimes used in order to increase reliability. So sources of error include these things. It could come from the observer. It could come from the equipment, like in the example of the scale. It could come from the environment. It could come from the participant. So for example, if it were coming from the observer, that means the way that I'm interpreting the behavior, if I'm the one that's making the observation, can cause problems. So if I'm administering, let's say, an IQ test to a participant and I misunderstand one of their responses, or I inaccurately score their responses, or inaccurately record them, then that source of error is coming from me. If, for example, I'm giving that same IQ test in a noisy environment or a dimly lit environment, then the error is coming from the environment, and that's contributing to the error and reducing reliability. And then third, error can come from the participant. Sometimes participants are hyper or hungry or shy or tired. I have kind of a funny example of this. When you go to graduate school in an applied area of psychology, you will learn to administer tests and measurements. It's actually a big part of what you do in psychology. And they will require you to practice on people. And when I took a class on testing children, you had to find your own children. So a friend of mine allowed me to use her children. And so when she went through school, I had to loan her my children because they were in the right age range for practicing the test that we were giving. And my son at the time was probably about 4 years old. And my friend came over to use him as her little guinea pig. And as it happened the night before, he had spent the night with his grandparents. And of course, you know, they'd fed him sugar and kept him up all night. And he was not very well rested. So he was not your most cooperative participant. So she set up her little station to test him. It was in the back bedroom. About an hour later, she came out, and I knew things had not gone well because it usually takes longer than an hour to give an IQ test to a kid. Anyway, she came out, and she said, "I'm sorry to tell you that he scored in the range of what was then called mental retardation." And I was like, "What?" And she said, "Well, he refused to answer the question. So he had his head down on the desk, and I would ask him, the first item was, 'What is a shoe? Can you tell me what is a shoe?' And all he would do is say, 'I don't know,' and put his head back down on the desk." So she had to give him a 0. So it didn't take very long to get through all the questions when he was refusing to answer them. Now that's an example, because I know he is not likely to fall in the range of mental retardation. However, that's an example of error coming from the participant. If they're not well rested, if they're not cooperative, if there's poor rapport, if they're fatigued. And so as someone administering measurements of human characteristics, you need to be aware of that and take that into account, especially in clinical areas. Once again, just to say, the more standardization you have, the more reliability you're going to have in your instrument. However, there's always going to be some amount of error. All right, now there are different types of reliability about which you should be aware. Mostly what we've been talking about is called test-retest reliability. So that gal getting on the scale and off the scale, she's performing test-retest reliability. So she's testing her weight over time. So the way these types of reliability are computed is as correlation coefficients. So her weight at time 1 is a score. She gets off the scale, and then she tests it again. Her weight at time 2 is a score. Correlating those scores together over multiple participants would allow you to test the reliability of this measure over time. That is called test-retest. It's pretty self-explanatory. Now, the amount of time varies greatly. So you might weigh yourself at time 1, which is Monday, and then weigh yourself again at time 2, which is Wednesday, or it could be a 5-minute period of time. It doesn't matter. That's determined by the person doing the measures. Now, interestingly enough, when I was working in a clinical area, a lot of times when I was testing a patient, I would have to review their medical record. And a lot of times patients would present for Social Security disability exams with some psychoeducational record where they had been given a test at some point during their school days, or school years, for assessment for special needs. And I would often see their IQ score from, say, when they were in 3rd grade. And now I'm seeing this patient, and this patient is now 50 years old. And it was always very affirming to me to see that unless something major had happened in the interim, they'd had a head injury or become ill or something had happened to them, that usually, even that 30-year span of time for test-retest, their IQ score was still pretty reliable and usually within the same range of intellectual functioning. So that's an example of test-retest. Parallel forms reliability is when you're testing different versions of a test, and you can even do different versions over time. I'll give you an example of parallel forms reliability, and it occurred when I first started working at MCC, when in order to stop students from looking on one another's papers in her large 101 class, another faculty told me that she had created 2 different versions of her 101 test. So for the first version, which she put on pink paper, she just created the test as she ordinarily would, choosing items from the test bank and putting them on this pink sheet of paper. And then for the second version, which she put on yellow paper, she scrambled the items. And then she had her students in that large classroom assigned every other student to a different version. So she handed them out down the rows, pink, yellow, pink, yellow, pink, yellow, so that it wouldn't be helpful to students to look on one another's papers. If you've ever been in BP4 and BP5, students are jammed in there like sardines. So it's kind of tempting, I think, to look over, and she wanted to stop that from happening. Anyway, when she got those tests back, she correlated the scores on those exams and found that the students getting the yellow forms did much more poorly than the students getting the pink forms. And that's because the yellow form students have the scrambled items. They did not have the advantage that the pink form students have, where the items were delivered to them in the order in which they learned the information. Isn't that interesting? So those items were picked out of the chapters in the order that they learned them or read about them or studied them, and the students with the yellow forms were lacking that advantage. So she did something to adjust the scores. I don't remember what it was, but that stood out in my mind as a test of parallel forms reliability, testing different versions of the same test against one another. The third type of reliability is called inter-rater reliability, and that's used only with behavioral observations where you are testing the reliability of a measure across persons, people, the ones doing the measurements. So if I was asked to go time the amount of time in a 5-minute period that an autistic student spent engaging in self-injurious behavior, and you were asked to do the same thing with the same student during that same time frame, then should our ratings not be pretty much in agreement? There's going to be some error, of course, because that's a little bit subject to interpretation. But those two scores should be highly correlated if they are reliable. And then last is something called internal consistency or split half. And this is a type of reliability that examines reliability across items on a test. So in that case, for split half, I could correlate scores on odd items with scores on even items, or I could correlate scores with the first half of the test, say items number 1 to 20, with the second half of the test, say items number 21 to 40. Sometimes that's called internal consistency. Internal consistency requires that you correlate scores on items with each of the other items. And for that, you can use Cronbach's alpha, which is the average correlation of each item with all the other items, or Cohen's kappa, which is a measure of inter-rater agreement where 0 is there are no agreements ever and 1 is there is agreement all the time. Those are formulas that are a little more complex that measure internal consistency. But this type of reliability all looks at internal consistency of the items on the test itself or the measure itself. That, of course, is used mostly for self-report measures. All right, so that's reliability. Now we're going to talk a little bit about validity, which is the other important psychometric property. Validity is also computed using a correlation coefficient. However, where reliability refers to consistency, validity refers to accuracy. And that is the veracity of it. Does the measure of this variable measure the thing that you are designing it to measure? In other words, is it capturing the construct and not some other psychological trait or characteristic? So again, validity is the truth of a measure, the veracity of a measure. Does it measure what is intending to measure? It's a little more difficult to assess when the measure is indirect. How do you really know that you're measuring what you think that you're measuring? Well, just like with reliability, there are different types of validity. The first type is called face validity. I'm going to switch over to this slide to show you this. Face validity is considered the weakest form of validity because it's not really necessary as long as the measure is reliable and valid in other ways. You'll understand what I mean when I explain this. Okay, so here are some sample items from the Beck Depression Inventory. The Beck Depression Inventory is a common measure of depression. It says that it measures depression, and it looks like it measures depression. What do I mean it looks like it? Well, I'm looking at these items. Suicidal ideas are a symptom of depression. Feeling inhibited at work is a symptom of depression. Loss of libido or sex drive is a symptom of depression. And so when it purports to measure depression, it's asking about symptoms of depression. Therefore, on its face or superficially, this measure appears to be valid. Now, what I'd like you to do is look at this next slide. Here we have some items from a very well-known personality inventory known as the MMPI. That stands for the Minnesota Multiphasic Personality Inventory. If you haven't heard of it, you should have heard from it. If you're a psychology major. It's now in its second revision. The original test was designed in the 1940s and used up until sometime in the 1980s. It was a highly reliable and valid measure, despite the fact of the way it was designed, which was kind of weird. In the 1940s, it was designed using a method called the known groups method, which is that the designers from Minnesota administered tons of thousands, perhaps, items to people in a psychiatric facility who had known diagnoses. So what kinds of patterns do we see, for example, in schizophrenics? How do they answer these items? How do people diagnosed with depression answer these items? How do people diagnosed with anxiety, which on the test is called psychasthenia, how do they answer the questions? And on and on and on. So they were known groups, and they looked for patterns in those groups. And then for the control group, this always makes me laugh a little, they used the visitors to the mental hospital. So I guess at the time they didn't know a whole lot about the genetics of mental illness, but that was the control group, the normal control group. Anyway, since they know about patterns in the way these different known groups respond to the items, the instrument did not have to have good face validity. So for example, item number 1, and it's all true false, the MMPI. If you go on in psychology, you'll probably take it. I've taken it hundreds of times. Well, maybe not hundreds, tens of times. It's very long. It's 548 items, I think, but they're all true false items. And this is the first one. True or false, I like mechanics magazines. Well, that item has poor face validity. I do not know what the pattern might be depending on how I answer it. So in other words, do schizophrenics tend to answer true to that? Do people with depression tend to answer false? Or maybe normal people answer false? I have no idea. I can't tell on the face of this. So the MMPI has poor face validity, which actually turns out to be a pretty good thing. In some instances, you might want a test to have poor face validity. Why? Because you don't want the people taking the test to be able to skew the outcome in some way. And that's one of the things that makes the MMPI-2 very useful. Now, some of the items do have good face validity. For example, I believe I am being plotted against. I'm pretty sure a true response for that loads on the scale for paranoia, but I guess I'm not guaranteed. I do not tire quickly. I think a false to that might load on depression, but again, I don't really know. When I get bored, I like to stir up some excitement. I don't know which one that loads on. Probably thinking maybe the mania scale. But again, poor face validity prevents me from skewing the outcome so that I might appear more mentally ill than I am or less mentally ill than I am, depending on my motivations. So here we are back at the different types of validity. That's face validity. Concurrent validity is when you correlate scores on your measure of focus with scores on another existing measure that measures the same construct. So for example, if I'm trying to formulate the St. Peter Depression Scale, once I get it to a rough form and I'm administering it to participants, I'm going to probably want to administer them the Beck Depression Inventory and see if the scores on my scale correlate with their scores on the Beck Depression Inventory, because that is a known and established measure of depression. If I'm measuring the same thing, of course they should be correlated. The third type of validity is called predictive validity, and this is best explained with an example. This type of validity questions the degree to which your measure predicts behaviors that reflect the construct. So here's an example of a study I read once where they were examining the predictive validity of the measure of a need for achievement. Need for achievement was a psychological personality trait that was proposed, I don't know, way back in the 60s or 70s. And it described people who were very ambitious or driven. And it was called need for achievement. And so they wanted to establish the validity of a measure they designed for children and their need for achievement. So what they did was administered this proposed measure to a group of children and then set up one of those ring toss games that you've probably seen at carnivals, where there's like a post in the ground and the participant has some rings and they attempt to toss the rings onto the post for prizes. The difference being with this ring toss game that they allowed the children to stand whatever distance they wanted from the post to see if their score on that measure predicted the distance that they chose to stand away from the post. And interestingly, they found a strong correlation. And that was that children who had low need for achievement scores tended to choose to stand a moderate distance from the post. Children with very high need for achievement tended to either stand very close to the post where they were guaranteed that they would get the ring onto the post, or very far from the post where it would be more of a challenge and that they would try their best to try to get that ring on the post. So it was kind of an interesting way of establishing predictive validity for that measure of children's need for achievement. The last type of validity is called construct validity, and this one requires a little bit more explanation. Construct validity is a type of validity that attempts to establish the truth value of your measure through two subforms of validity known as convergent and divergent validity. Construct validity is established over a long period of time through use of convergent and divergent validity. Convergent validity is when you are wanting scores on measures to come together. So you want the correlation to be high. The two measures that you are using are measures designed to measure the same construct, but using different modalities. Okay, so here's an example. Let's say I'm looking to measure depression. I could measure depression using a self-report measure and a behavioral observation. So I'm using, let's say, the Beck Depression Inventory, which is that paper and pencil self-report, and using a behavioral observation, for example, recording the amount of time a patient spends crying each day, which is a symptom of depression. I'm using two different modalities, but they're measuring the same construct, so I want those to converge or be highly correlated. So convergent is same construct, different modalities, goal is to converge. In contrast, divergent validity is used when you are examining two different constructs, but using the same modality. So, as another example, if I'm constructing my own paper and pencil measure of depression, I might want to correlate that with a paper and pencil measure of anxiety. In this case, I'm using the same modality, but I'm measuring a different construct. So I want those scores to diverge. I want that correlation to be low because anxiety and depression are different constructs. If they are highly correlated, that's telling me that there's something about the measurement modality that's causing that correlation, because those constructs should not overlap. So construct validity is demonstrated over time through use of convergent and divergent assessment procedures, convergent and divergent validity. With convergent, your goal is high correlations, same construct using different modalities. Divergent is low correlations, different constructs using the same modality. If you have to go back and listen to that again, I don't blame you. But hope that's pretty clear-cut. Message me if you have any questions. Again, reliability and validity are quantified using correlation coefficients. So I'm going to draw this out for you with this shaky little pen just because we're going to revisit this kind of design later. With any correlation, you have one variable which is denoted as X. That variable is often referred to as the predictor. Y is the second variable, and that variable is often referred to as the criterion. Here I have indicated participants. Let's say I have 10 participants. Participant 1, 2, all the way down to 10. So this shaky pen reflects the participants. Okay, so participant number 1 has score Z here, and then has score Z here. If X represents time 1, Wednesday, and Y represents time 2, Friday, then that's test retest. Okay, that's a measure of reliability. As an example of validity, if X were for predictive, the score on the measure, and Y were the score on the behavior, like the ring toss game, then you're establishing predictive validity. So all of these different forms of reliability and validity can be thought of just as a correlational design, where X is a score at the first time, with the first observer, with the first type of measure, with the first form of the measure, and Y is time 2, observer 2, version measure number 2. Okay, so they are all just reliability and validity coefficients. If you look in the administration manuals for any reliable and valid test or measurement, you will see all of these different types of reliability and validity reported as correlation coefficients. All right, so we're going to zoom through this because this is addressed in lab. The meanings of those numerical values can be nominal, ordinal, interval, or ratio. Of course, nominal refers to just basically names or ways of identifying different categories. So let's say kids' baseball jerseys. They have numerical values on the back of them, but only so that you can identify that player. Number 5 doesn't mean anything in terms of quantity or category even. It's just a way of identifying that person. Ordinal gives you names and also gives you rank. Okay, so if I give out those baseball jerseys to those kids, lining them up from shortest to tallest, then the numbers themselves don't have any meaning other than I know in what order they are. I know number 11 is taller than number 5, but I don't know by how much. Okay, interval scales adds to what extent the values differ. Okay, so with an interval scale, every distance between the points is predictable and regular. So an example of this might be, let's say I gave out the jerseys, but on the back of them, well, I'm not going to use that example. and I don't know how to back up, so I'll give you a different example. Rating scale items, those are interval scales. So rating your self-esteem on a scale of 1 to 5, those numerical values are interval. The distances between the points are regular, so 1 to 2 is the same as 4 to 5. However, those values are arbitrary. So if I rate my self-esteem at a 4, what does that really mean? And a 1 to 4 scale could also just as easily be a 0 to 3 scale. So the numbers themselves don't mean anything in terms of quantity. They're really just markers. And then the ratio scale is actual quantity. So it has a true 0 point. None means, 0 means none of that quality or characteristic. So you should know these. We're going to be working with these a little bit more in lab if that seems kind of a scant explanation. But you should also be somewhat familiar with those from statistics. The reason it's important to understand these now is because they drive a couple of different things with your research project. One is that the scale of measurement drives your choice of statistical analysis. So if, for example, you are measuring, let's say, gender on a nominal scale, 1 is male, 2 is female, that's going to limit the number of tests that you can, it's going to drive what test you can use to evaluate your hypothesis. But obviously some variables can only be measured according to one scale or another. So for example, gender is nominal. Age in years is ratio. You can be 0 years old, you can be 40 years old, however many years, it's a quantity of years. Now, some variables can be changed from one scale to another. So let's say I asked you your age in years, and you told me you were 30. Well, that's a ratio measure of age. But let's say for my hypothesis, I said that different developmental stages of adulthood result in different levels of comfort with technology. Well, if I ask you your age, but my hypothesis includes developmental stages of adulthood, I will then have to take your age and assign you to a category such as maybe young adult, middle-aged adult, elderly adult. And if I'm defining it that way, 1 is young, 2 is middle, 3 is elderly, then I've changed a ratio scaled variable into an ordinal scale. So if possible, measure your variables on a ratio scale, because if your hypothesis calls for a different scale of measurement, you can always convert it, but you can't do it the other way around. If you ask a person to describe themselves as young, middle, or old, and they put themselves in one of those categories, because you don't know the distances between those points, all you'll know is that's how they've described themselves. You will never know their actual age. So they give different amounts of information. Ecological validity is another consideration, and that just has to do with measuring your variable in a way that it appears in the real world. So an example of this is if one of your outcome variable was like jury verdict, let's say. Well, you're going to want to measure that on a nominal scale, because the outcomes of trials in the real world are either guilty or not guilty. That's a jury verdict. Juries don't rate how guilty you are on a scale of 1 to 7. They don't measure your guiltiness in a ratio manner, like how many pieces of evidence, let's say, are there actually against you. No, it's all or nothing. The outcome is either, well, I guess it could be a mistrial, but generally guilty, not guilty, that's nominal. So ecological validity sounds complicated, but it's just suggesting that you use the scale of measurement that best reflects the way your variable appears in the real world. I said this in lab 2, in one of the labs, but I think it was lab 4, but I want you to know this again. When you are designing measures, if you're designing your own measure of a variable, you need to make sure that all items that measure that variable are on the same scale of measurement. So don't mix yes/no items with rating scale items, because when you go to combine those scores, add those scores together, add each of those item responses together to make a single score, you're not going to know how to do it. Now, you don't have to use the same scale of measurement for both of your variables. So you could measure one variable on one scale, but all those items have to match. The other variable can be on a different scale from the first one, but all of those items have to match. So in other words, you can have one variable measured with all yes, no items, and one variable measured with all rating scale items. But they don't have to be the same. They just have to be the same scale of measurement within the variable, not across the variables. I hope that makes sense. If not, again, send me a message and I'll explain it to you more. All right, just some miscellaneous aspects of measurement in our last couple of minutes here. One, you will see in the literature that, as I mentioned before, reliability is better with multiple measures. They can serve as a cross-check. You guys are not required to do that for your project. That's above and beyond the scope. Be aware that with behavioral observations, participant reactivity can be a problem. And that is sometimes participants behave in ways that do not reflect their true behavior simply because they know they're being observed. In that case, you can use a procedure called habituation. And that is observing the participant for a while until they kind of get used to or habituated to the observation. And usually then participants will begin acting normally again or acting in a way that's more representative of their real behavior. And then you can start collecting data. Third, be aware of range effects, specifically floor and ceiling effects. If you are measuring, in particular, some kind of skill, like a memory test, let's say that's your dependent measure, if you make it very difficult, scores are going to be restricted at the low end of the range. That's called a floor effect. They can't get any lower. I had a student do that one time. She designed a memory test, and it was so hard, nobody was getting any of the items. Well, that's not creating a normal distribution of scores, which is an assumption of central limit theorem. Remember that most people perform average on any measure or characteristic. By definition, most people are average. Well, you're violating that if you're instituting a floor effect by making something too difficult. And then, of course, you'll get a ceiling effect if it's too easy and everyone's getting most of the items right. You're bumping into a ceiling there. So be aware of range effects if you are designing your own measures. You're going to want to test them out a little bit first. If you're using someone else's measure or an established measure, you're probably okay. Be aware of experimental bias, especially with interviews or behavioral observations, and that is the degree to which the outcome or the measure is influenced by personal beliefs or expectations of the experimenter. To overcome experimental bias, you'll see in the literature sometimes experimenters use single blind studies where the experimenter doesn't know who's in what category or what condition, or double blind studies where neither the experimenter nor the participant knows anything about which group they're in or what the manipulation of the independent variable is. And then last, pilot studies are recommended. You guys don't need to do pilot studies, but as I said, if you are doing an experimental study where you're exposing participants to different treatment conditions, or you're creating your own measure, then you might want to just run it by a few family members or friends, because that can help you see errors or problems, can help you detect floor and ceiling effects. It can help you clarify instructions if there's confusion on the part of your participants. But you don't have to do a full-scale pilot because obviously it takes time and resources. This was an activity that I had people do in class. I'm not going to have you guys do that. I should have eliminated the slide, but you can read it over if you want and try it. If you want to just, have a little exercise to do on your own. Otherwise, this concludes Defining and Measuring Variables Part 2, and I will see you in the next lecture where we will discuss selecting research participants. Have a great week.